Hey everybody, it's Mr. Carr again. We're going to be looking at 5.2 day 1 here. We talked before about simplifying our trigonometric expressions. Now we're going to kind of use our identity idea. We're going to verify our trigonometric identities and determine whether the equations are our identities. Okay, so what does that mean exactly? So let's look at this scenario here. We want to verify that this is a trigonometric identity. And does the tangent squared of x plus 1 divided by 1 minus sine squared of x equal the secant to the fourth of x? So there's a couple things to focus on. Dealing with this secant to the fourth, so I'm probably going to be using this one. Okay, and I'm also dealing with our sine squareds and everything, so I've got this one going as well. Okay, so first thing is, probably should have looked at that. This is my tangent squared x plus 1. So I'm going to replace tangent squared x with secant squared x. 1 minus sine squared of x is the same thing as if I take this and just subtract it over. So cosine squared of x equals 1 minus the sine squared of x. So that means I can replace 1 minus sine squared of x with cosine squared of x. So from here, I'm going to keep going through and see, do I come up with secant to the fourth of x? So from here, I've got reciprocals with secant to squared and cosine squared, but I don't want to change secant squared into a reciprocal. I want to keep it as secant. So that means this is the same as the secant squared of x over 1 over the secant squared of x, because that's what cosine squared of x is the same as. Well, that's the same as taking the secant squared of x multiplied by secant squared of x over 1. I'm multiplying by its reciprocal. Since I'm multiplying the same thing through like this, that's kind of like taking x squared times x squared. So this turns into, secant to the fourth of x. So it does check out. Okay. So that's what I'm trying to identify or trying to confirm here. Do I have the same thing on both sides of my equation? Okay. So let's do another one. Verify this one. Verify that -2 cotangent of x equals all of this. So again, you notice that we're dealing with a fraction or two fractions here. So let's go ahead and put those together. So again, we can multiply by the other denominators here to make them common denominators. And thankfully, they are conjugates of each other. We're going to do that to the numerator and denominator for both same things here. So 1 minus cosine of x. Okay. So when I do that, I'm going to double. So I've got sine of x is going to distribute here. Sine of x will distribute here. Might be a little bit easier just to do this. This is going to be a plus a negative sine of x, and that's going to distribute then. So on the left side here, I'm going to have sine of x minus, sine of x cosine of x plus, this is going to be a negative sign multiplied through, so it's plus a negative sine of x minus sine of x cosine of x all over, and then when this distributes with the conjugate, remember, that's going to be the same as taking 1 squared minus cosine squared. Okay, from here, I'm looking at what can I simplify? Well, I can simplify. We have here, let's see here. That cancels out with that. That's a negative, that's a negative. So that turns into a -2 sine of x cosine of x. Okay, I want to put those together as one expression like that. 1 minus cosine squared, that's the same as this being manipulated because this is sine squared x is equal to 1 minus cosine squared x. Okay, so I'm going to replace now my denominator with the sine squared of x. From there, since we have sine of x and x squared on the bottom, basically that's going to get rid of that. So this turns into -2 cosine of x over the sine of x. Okay. Now remember, from before, we can treat this as -2 times this. Well, cosine of x over sine of x is the same as cotangent of x. So this is just, -2 times the cotangent of x. Okay, remember, the cotangent of x is the same as cosine of x divided by the sine of x. So we're using that identity for cotangent to replace that to simplify that here. And that is what I had in the beginning. So that checks out. Remember, the goal is to try to get from here to here. Like take your more complicated version, see if you can get it down to the less complicated version. Okay, so we got another one here. We got cosine x secant squared of x tangent x minus cosine x tangent cubed of x. Does that equal to just sine of x? Whew. So first thing I'm going to notice when I look at this is we've got cosine of x and cosine x tangent x in both of these terms. So I can factor out cosine x tangent x out of both of these. What are we left with is secant squared x minus tangent squared x. Because remember, I had tangent cubed. So I factor out one tangent, I'm left with tangent squared. Okay. From there, cosine of x tangent x. Remember what that turns into. Tangent is the same as sine divided by cosine of x. So what I'm left with there is something to cancel those two out. Okay. But secant squared x minus tangent squared x. I'm going to go back to this property here. We haven't really done this a whole lot. If I subtract tangent squared over, 1 is equal to secant squared x minus tangent squared x. Now, potentially, if I, let's say, subtract the other way, -1 would be like the flipping of these. It would be tangent squared x minus secant squared x. So since this matches to this, I can replace this with a 1. Since the cosines cancel each other out, I have sine of x times 1. My answer here is just sine of x. And that's it. And that it's a very complicated thing, but turned into this much simpler version going through these steps. So again, you may take different steps than I take, but the key is, can you get to that simplest version? So you're always looking for other fractions, other Pythagorean identities that you can apply to see if you can get there. Okay. And that's it for today. All right. Take care, everyone.